Hey guys, we are going to continue working in Chapter 12, Section 1, focusing on systems of equations. Our last video looked at different methods for solving systems. We looked at graphing, something called the elimination method, the substitution method, and so today what we'll do is we're going to go ahead and start looking at some applications. So when in real life would you have to create a system of equations? So we'll do a couple together, and then your assignment for the day will be a worksheet to try a few on your own, okay? This says systems of equations occur in many real-world applications. The simplest situations involve two quantities, meaning you'll have two variables, and they are two linear relationships. And what that means is we will not be dealing with exponents, we'll just have our single variable. Okay, so we are going to do some of those now. Here is the first example. A ball game is attended by 575 people. Total ticket sales are $2,575. If ticket costs $5 for adults and $3 for children, how many adults and how many children attended the game? So again, we have two variables. So let's say A represents the number of adults who go to the game. And let's say C is the number of children that attended the game. Okay, so we have two variables, and we also have two things that we're looking at, which leads itself to create a system. We have one thing is how many people attended the game. We know the number of adults plus the number of children equals 575, because it says a ball game is attended by 575 people. The other thing that they're focused on is ticket pricing. Tickets cost $5 for adults, so it's $5 for adults plus $3 for children. The total sales were $2,575. So here's a system of equations that would represent this scenario. Okay, now let's go ahead, and I really like the elimination method. So if I'm going to use the elimination method, what that means is I need to create opposites in front of one of my variables. I'm going to go ahead and cancel C. So if I want to cancel C, I can multiply the whole top equation. You'd have to multiply every single term by -3. So I would have -3A minus 3C. -3 times positive 575 is -1,725. Now the second equation I am not changing. The reason why I'm not changing this is because if you look in front of the C, I have opposites. They're both a 3, but one's positive, one's negative. So now when I add these together, the C will be eliminated, and that's why it's called the elimination method. -3A plus 5A is 2A. -1725 plus 2575 is 850. To solve for A, which represents the numbers of adults that attended the game, simply divide by 2. 850 divided by 2 is 425 adults. Okay, but that doesn't answer the full question. It says how many adults and how many children attended the event. So what you're going to do is I have to go ahead and define the number of children that attended, change A in one of the two equations to 425 and solve for C. I'm going to use the top equation. So A, we already know, is 425, plus the number of children has to equal 575. To solve for C, you'll have to minus 425 to the other side. 575 minus 425 leaves us with 150 children. So there is a real-life example of when you could create a system of equations. Another way, or another time that you're going to see systems of equations very helpful, is if you're trying to make a mixture of something. And so example B is kind of talking about that type of scenario. A cafe sells 2 kinds of coffee in bulk. The Costa Rican sells for $4.50 per pound, and the Kenyan sells for $7 per pound. The owner wishes to mix a blend, okay, so you're going to blend to make one mix, that would sell for $5 per pound. how much of each type of coffee should be used in that blend. Okay, so again, we have two variables. I'm going to say C for our Costa Rican blend, and let's go K for our Kenyan blend. Okay, we are looking at two different things. You want to take two kinds of coffee and mix them together to make one mix. So C plus K equals 1. Two different kinds to make one blend. The other thing that you're focused on is the price. So Costa Rican coffee is $4.50 per pound. Kenyan coffee is $7 per pound. You want it so when you go ahead and make the blend that it's $5 per pound. Okay, so two kinds of coffee blended together to make one mix. Costa Rican is $4.50 a pound. Kenyan is $7. Your goal is to have the blend sell for $5 a pound. So again, we're going to go ahead and solve the system of equations. You could do substitution. You could use elimination. I love elimination. So if I want to solve using elimination, let's say I want to cancel K. This is positive 7K, so I need to make this negative 7K. So I just have to multiply the whole top by negative 7. Negative 7C minus 7K equals negative 7. The bottom equation I am leaving the same because now if you look in front of the K, I have opposites, a positive 7 and a negative 7. When I add these together, they eliminate, thus the elimination method. Negative 7C plus 450C is negative 250C. Negative 7 plus 5 is negative 2. To solve for C, which is what percent of the mixture needs to be Costa Rican, negative 2 divided by negative 2.5 is 0.8. Now, if I want to see what K would be, I can go back up here to solve for K. I can change C to 0.8. So 0.8 plus K equals 1. If I minus 0.8, 1 minus 0.8 is 0.2. So what this tells us is if I am making this exact blend, okay, I am the cafe that wants this blend to be $5 per pound. I need 80% of the blend to be the Costa Rican coffee, and I need 20% of the blend to be the Kenyan style coffee. Okay, so there were two real-life examples. Your worksheet follows these two things in a pretty similar manner. So again, try a few on your own, and then we will move on to our next idea, which is solving 3x3 systems of equations. Kind of a fun thing. I hope you guys are doing well. I miss you tons. Enjoy your worksheet. Talk to you later.